Hello there, guys. Good morning. Yeah. So I'm Krishna Durai. I come from Cisco.
Hi, I'm Yannis. I'm a software engineer at Arrikto.
And today we both are going to present our journey in enabling Kubeflow with enterprise-grade auth for on-prem deployments. First things first, what is Kubeflow? I would like to know how many of you folks use Kubernetes in production. I hope it is most of them. Yeah, that's a good number. Of course, this is KubeCon. Yeah. How many of you guys run ML workloads on top of Kubernetes? I'll tell you guys, Kubeflow sits right there. It is the machine learning toolkit for Kubernetes. And Kubeflow is built in such a way that it is a suite of services which you can configure yourself and customize yourself. And as I talk about building Kubeflow, who builds Kubeflow? Kubeflow is completely open source. If you look at it, there are 40 plus companies contributing to Kubeflow right now. And in the past 28 days, we have had so much traction. Around 500 PRs being created and 100 plus unique contributors contributing. So truly, it is ML innovation in open source. Before we head into the auth discussion, what we would like to do is give you a brief idea of how Kubeflow is structured by showing you some diagrams and describing it. Oh, here is the overview of Kubeflow. And typically, this is how your ML workflow looks like. The idea behind Kubeflow is that it is composable, so that you can bring in your own applications. But that doesn't mean that Kubeflow has its own applications in itself. Kubeflow developers also develop some applications. There are two sections of applications for this talk, the low-level services and high-level services. I'm going to call it that way because low-level services are going to implement custom resources using custom resource definitions. And those are picked up by controllers. It is very Kubernetes native. Likewise, high-level services are web UI based. So if you look at an overview diagram of how it logically looks like in Kubeflow, this is how it is. Please take a look at the TF job operator, which I've shown in low-level service APIs. So TF job is going to implement a custom resource, and it has an operator which will pick up these custom resources and execute that. So by virtue of this, we get access to the Kubernetes API server, definitely, isn't it? So if you're thinking, if you can get, list, watch, delete, etc., you can do that. How are you going to use TF job operator? It's very simple. Use kubectl, apply TF job. Likewise, when you talk about the high-level services, which you can see towards your right, few of the examples are Jupyter notebooks and pipelines, which help you build orchestrated ML workflows. And since these require a web UI, you get a notion that you need routing and gateways. And we have used Istio Mesh to enable this. Let's take a look how we use the high-level services. So this is the Jupyter web UI. You would want to run something like a TensorFlow job and hit run. What it does indirectly is use the low-level APIs through the Kubernetes API server. And this is the typical workflow in the manner which Kubeflow services run. One of the core aspects of Kubeflow is to provide multi-user isolation and multi-tenancy. So each data scientist gets a self-serve environment so that they have a very unique view of Kubeflow themselves and are not aware of other users unless they want to share their own workspace. What we have done is implement this through Kubernetes namespaces. Doesn't that seem obvious? Because it is so easy. Namespaces isolates Kubernetes resources, and Kubeflow has taken advantage of it. But the story does not end over there. Today, we are going to focus on two questions. How do these services know that this is the user This is the identity of the user. We are going to talk about how are we authenticating at each level, and how do we restrict the users? How do we authorize based on certain policies? This talk is precisely going to answer these questions. And to start with it, Yannis is going to speak about some of his great implementations in the high-level service authentication and authorization. Go ahead, Yannis.
Thanks a lot, Krishna. So overall, we have Kubeflow, a machine learning platform on top of Kubernetes. And we need a Kubeflow cluster to be used by multiple people, by multiple users, by multiple teams, by multiple projects. So how do we go about doing authentication and authorization? First, we'll talk about authentication and authorization in the high-level services of Kubeflow. That is the UI-based services. Why do we need UIs? We don't want to expose the data scientist to all of the underlying complexity of Kubernetes. If possible, we'd like the data scientist to not even know there's Kubernetes, because many data scientists will prefer this kind of workflow. So let's see what this will look like. So suppose you're a user. You go to your browser, you go to the URL bar, you put in the Kubeflow address, you hit enter. What happens? The user browser will issue a request. That request will hit the Istio gateway, which is what exposes the Kubeflow cluster. Now, the Istio gateway will check for a specific session cookie on that request. If that session cookie is either invalid or missing, the Istio gateway will redirect the user to log in using OIDC. Now, the user's identity can be retrieved in a number of different ways with a number of different authenticating backends. We support LDAP, or Active Directory, an external IDP provider like Google or LinkedIn or GitHub, or even a static user file. Once the user is logged in and has that special session cookie, Istio Gateway will let the request pass, but also add a special header. That header contains the user's identity. So now, an application of Kubeflow, all that an application of Kubeflow has to do is read that header in order to learn who that user is. So for example, let's suppose the user is Sarah, and Sarah wants to create a Jupyter notebook. Now, how will the application backend know if Sarah is allowed to do that? The question is Sarah allowed to create a Jupyter notebook in namespace X? We delegate that authorization decision to Kubernetes using Subject Access Review. Subject Access Review is an API that allows us to ask Kubernetes exactly that question. Is Sarah allowed to create a Jupyter notebook in namespace X? And Kubernetes answers yes or no. Now, what if the resource we had to protect was not a resource that lives in the Kubernetes API server? What if it's an actual network resource? For example, only Sarah should have access to her own Jupyter notebook server, and no one else. This cannot be done with Kubernetes RBAC, because Kubernetes RBAC can only protect resources that actually live in the API server, like CRDs. So the way we do that is with something called Istio RBAC, and that's how we protect the actual network service resources. So access to Sarah's notebook should only be done by Sarah. So I'll leave this for a second so you can take your photographs. And let's go over the important design decisions that we made when we made this design. Our first design decision is to use OIDC. OIDC is an open and standardized OAuth flow, which in plain words, basically it's a procedure for getting a user's identity out of an identity provider, like Google, like LinkedIn, like an LDAP database, like anything. And it's popular and secure and open source. The second design decision that we made was regarding the service mesh. Kubeflow has opted for using the Istio service mesh for the following use cases. First, for HTTP path routing. For example, /notebooks should go to notebooks, /pipelines should go to pipelines. And the second reason is for the RBAC authorization for network service resources. As we talked about, access to Sarah's Jupyter notebook server should only be allowed to Sarah. And it's also extensible and field-featured, and this has helped us out in multiple scenarios. For example, Istio does not natively support IDC, the whole flow. Istio only supports the last part of the IDC flow, which is the token verification. So this is the whole IDC flow that you see here, and the blue rectangle is the only part that Istio actually supports natively. So we had to find a solution for that. What did we do? We dug deeper, and we found the Envoy filter object, which allows you to actually configure the underlying Envoy proxy of Istio. And we use that to enable the external authorization filter of the Envoy proxy, which adds the following basic but very powerful behavior. So when a request hits the Istio gateway, the gateway will ask another small service called the Auth service, is this request allowed? The Auth service can answer yes with 200. It's an HTTP code. The Auth service can answer no with 403. Or the Auth service can redirect the user and begin an OIDC cycle. We use this simple but powerful functionality to build our own OIDC of service, which we built from extending an open source project. And from our findings in the Istio community, it seems that we're considering this approach as well. You can learn more about this in this URL. I'll leave this for 1 second so you can take your pictures. Hope you got them. All right, so the third design decision is about the identity provider. We knew that in order to drive enterprise adoption of Kubeflow, we had to make sure that it will integrate very smoothly with many different kinds of authentication backends. And that's why we chose DEX as the OIDC provider. DEX is an amazing project from CoreOS, and it will integrate smoothly with an LDAP or Active Directory database, an external IDP like Google or GitHub, or a static user file. So you can use it in many different ways. So after all of this said and done, let's see what this actually looks like from a user perspective. So I'm going to go to my demo here. OK. And this is a recorded demo. I didn't really trust the network on this one. But you can try it out yourselves at home. So the user goes to the Kubeflow address. The Kubeflow address immediately redirects the user to log in to DEX. Now the user will try to log in with LDAP. We will show here our LDAP database. So we have 2 users, James and Sarah. And at first, we'll try to log in as Sarah. So Sarah fills in this form, presses login, and after Sarah logs in, she will be redirected to the Kubeflow Central dashboard. And she's prompted by this screen. What this screen tells is that Sarah doesn't yet have her own self-serve environment, her own namespace. So we're going to create one for her. And that's what this prompt does. So Sarah now has her own self-serve environment, her own namespace, selects that, and tries to create a notebook server. So she selects the name that she wants, and just hits enter. Launches the notebook server, and once it's ready, connects to it. Pretty standard workflow. Now, what happens if we have another user? We have James. So James goes to the Kubeflow address, and James is also redirected to DEX in order to log in. So James will select login with LDAP. James will put his credentials in and log in. And now James already has his own environment, so he won't be greeted by the prompt that we saw in Sarah. Now, James goes to see his notebook servers. He already has one and connects to it. Now, let's see the interesting part. What will happen if James tries to access Sarah's notebook, or if Sarah tries to access James's notebook? This shouldn't happen, right? This is the Istio or bug part we talked about. they get RBAC access denied. This is what the is to RBAC does. And to do that, we check the header that we talked about. Now, James will try to do the same thing and fail. And finally, let's see what happens if James tries to access Sarah's environment from the Kubeflow Central dashboard. James will get a message saying user James at kubeflow.org is not authorized for namespace Sarah. I don't know if you can see it here, but it's there. I can zoom video, sorry. So this is what we talked about on the presentation. Each user has their own environment, which can be accessed by other users. They're isolated. That's what we showed. So let me actually go back to the presentation. And OK, so we showed what this actually looks like from a user perspective. Let's see an overview of where we're at. So this is what we showed. We showed authentication authorization of the high-level service, the web UIs in Kubeflow. Now, what happens if we want access to the Kubernetes API as the user that we are? This is not as simple as it may sound. There's some complexity there to achieve that. This is the second part we're going to talk about, access to the low-level services, access with kubectl. And Krishna is now going to present the excellent work that he's done using the UIDC plugin of the Kubernetes API server.
Thank you, Yannis. That was fantastic. Now let's dive into the low-level services Auth solution. First, let's look at our design decision. Very early in Kubeflow, we made a decision that custom resources and controllers is the way to go for low-level APIs. So that straight away brings in the Kubernetes API server support. Likewise, two additional things which we get along with it is authentication and authorization using RBAC. And using these design principles, we'll try to enable authentication. One important thing to note is that the identity at high level should be always equal to identity of low-level services. What I mean to say is that if a user is using Jupyter Notebook and trying to access some services, they should get a consistent experience when they are doing the same steps at a low-level API using kubectl, for example. So there are three methods to achieve this, to enable authentication on the Kubernetes API level. One is the OIDC plugin, which is straightforward. Just configure your Kubernetes API configuration, and you're all set. So this works on on-premise servers. There are two other methods called kubeOIDC proxy and service account jot to RBAC. These two methods work on managed clusters as well, and Yannis will later speak about them. I'm going to speak about OIDC plugin and how it is implemented in a simple schematic. User asks for a token from the external identity provider, gets back the token, enables kubectl with that configuration, and this is sent upstream to the Kubernetes API server whenever the user makes a call. And the Kubernetes API server sees whether if it is valid by using the help of the OpenID Connect provider. And likewise, the result comes back to the user. This is as simple as it is. Now, let's go into the authorization bits. This is going to be tricky because you are defining policies for the composable nature of Kubeflow. You can bring in your own applications, remember? So how did we manage to do that? We had a notion of a role associated with the user so that it is easier for us to manage all these policies. So Kubeflow defines now aggregated cluster roles. So we have three aggregated cluster roles: Kubeflow admin, edit, and view. And how do we define those? How do we mention these policies? So each and every service defines its own Kubeflow service role cluster role. So for TF job, it looks somewhat like this. For Kubeflow TF jobs view, we have the rules mentioned like this. So for each and every application, you can mention the role levels and such cluster roles. So the entire picture looks like this right now. And what happens through aggregated cluster roles is that this aggregates into main cluster roles defined by Kubeflow. And this can later on be associated to a user in a namespace. And this is what I'm going to talk about in the next slide. How do we use this? In the high-level access, user uses a Jupyter notebook, which then ultimately uses Kubernetes API to carry on its workload. What we do is have service accounts for each and every role. And these Jupyter notebooks are associated with those role-based service accounts at each and every namespace. And we create a role binding which says that, OK, this service account has access to only that Kubeflow cluster role. This is what we do. And it is as simple as that. And the Jupyter notebook is restricted to that role. When we head on to the low-level access, the kubectl access, how do we achieve the same? It is somewhat similar, but here what we do is define a role binding for each user. So every time a user is created in a profile, this role binding gets created. So for Sarah, we have associated her with a Kubeflow edit role. This is how simple it is, as it is. And in the demo, I'm going to show how we have implemented this for low-level access. So let me just head over to the demo. So what I'm going to do here is log in with user James, like earlier it was shown. And then switch over to James's profile, go to Manage Contributors, add Sarah as a contributor. The thing to note here is that when Sarah is added as a contributor, her default privileges are edit, Kubeflow edit. Next, I'm going to show what is the role binding created. As I told you, it is edit. So what we are going to do now is list what is there in edit. You can see that Sarah is associated with Kubeflow edit privileges. And then now we are going to delete this role binding so that we can change her privileges to view. Let me just show the view privilege. And then you apply the view privileges to Sarah. Now what I'm going to show next is I'll use James's context and create a TF job. So I'm going to use James's context now. Look at this TF job, which is a CRD definition, and apply that. You will see that this job is accepted because James has enough privileges. He is the admin for the James profile namespace. It has been created now. I'm going to delete it since James has delete privileges. Now I'm going to switch over to Sarah's role. OK, let me use Sarah's context. And then let me apply the TF job. You will see that this is forbidden because Sarah has only view privileges on TF job. And this is how we achieved authentication and authorization on low level. So heading from here on, we are going to see the alternative Kubernetes authentication techniques, which I promised. And Yannis will be taking it over from here.
Thanks a lot, Krishna. So excellent work regarding the OIDC plugin on the Kubernetes API server. And this is actually a Kubernetes native way of doing this. But for some reason, many managed providers wouldn't actually allow you to turn it on. So let's see what you can do in a way that works in every cluster. What if, instead of enabling the OIDC plugin in the Kubernetes API server, you had a pod that ran inside your cluster, exposed through standard Kubernetes methods, that spoke OIDC on one end with the user, and then proxied those requests to the Kubernetes API server using impersonation. So let's see how that would work. You are a user, and you issue requests using the OIDC interface to a pod running inside your cluster called the KubeIDC proxy. And once this pod authenticates who you are using OIDC, it will then proxy your requests to the Kubernetes API server using something called impersonation. So it's essentially as if you were the one doing the request. Now, this is an open source project by Jetstack. It's called KubeIDC proxy. It's a very interesting approach. It has its advantages and disadvantages over the OIDC plugin, but it's very interesting. I definitely suggest that you give it a try. The second approach is, what if instead of making Kubernetes recognize us as the user that we are, we made a service account with the same permissions as that user and give that service account to the user, because we control service account, but we don't control who Kubernetes will authenticate the user as. At least in managed platforms, we don't control the API server. So essentially what happens is when a user comes, we take the user's identity and we map it to a set of permissions. And we give those permissions to a service account and give the service account to the user, the service account token. And this mapping is done by a software called Jot to RBAC. It's developed by Banzai Cloud, and it's definitely a very interesting approach, which will also work in every cluster. Now, after all is said and done, let's see what takeaways and next steps there are from our journey. So, through our journey implementing and designing authentication and authorization for Kubeflow, we explored many different solutions. We saw what the ecosystem had to offer, and we developed our own techniques, which are universal and globally applicable, which means that if you have your own platform that you build on top of Kubernetes, regardless of what you do, this will probably also apply to you.
And another aspect to note is that all the solutions which you have used are open source. So you can go ahead and hack these open source solutions like Yannis did with the OIDC auth service and just contribute back to the community.
Absolutely. So what are the next steps for this? The first demo that we showed, high-level service authentication authorization using Istio IDC with LDAP and DEX. These are all things that you can try out today, right now. You can just go to the Kubeflow website, install Kubeflow 0.7, and you'll have an environment just like us. Now, the second part, the low-level service authentication authorization with kubectl access is being planned for Kubeflow 1.0. And speaking of Kubeflow 1.0, we are very excited to announce that it arrives on January 2020. Kubeflow 1.0 is the first major release of the Kubeflow project. It's a very important milestone, and we're very, very much looking forward to it. If you enjoyed this talk, and generally you enjoy multi-tenancy, I would also suggest that you attend the talk by Cam from Intel and Kunming from Google tomorrow at noon, which is also about multi-tenancy in Kubeflow. Thank you. Any questions?